Swift Squad, we're going to add a checkbox to your to-do list app using a custom protocol and delegate. We're going to learn about button state. We're going to cover SF symbols. We're going to cover how to create custom protocols and handle delegation. We'll review as exclamation point for subclassing and the not operator for toggling bools. For Tom Cruise, it was Mission Impossible Ghost Protocol, but for us, it is Mission Possible with Checkbox Protocol. Let's get at it, Secret Swifters. So up first, let's customize our dynamic table view cell. Get into main storyboard. Make sure that you've clicked on the cell. That's the one in our dynamically scrollable table view. We should have that up in the attribute inspector. Note that it says table view cell. And under the different styles, we currently are using basic, but we're going to select custom because we're about to customize this cell. Now, when we select custom, we no longer see the label that was inside of it. So let's click library, grab a new label, put it inside this cell. Remember, the label holds the to-do-item.name property. Position the label, then go back to the object library and drag a button out. Now the checkbox is actually going to be implemented using a UI button. So we'll drag one of those over and plop it just to the left of the label. Here's how the checkbox is going to work. Buttons have different states. If you pull down under state config, you see a bunch of different options there, including highlighted and disabled. We're going to work with default state and selected state. When the button is in default state, we're going to show an empty box. And when it's in the selected state, we're going to show a checked box. Now this button is going to display an image and not text. So I'm going to go down here to where it says button. That's just the default text that's put inside of this button. I'm going to backspace over to get rid of that text. Then go down to the image attribute, and if you pull down there, you would see any of the images that would be in our assets catalog. We don't have any in this app, but we see a bunch of other images. Now, starting with Xcode 11, Apple introduced a new font called SF Symbols. There's even an SF Symbols app that you can download if you want to browse through all of the different symbols. And so here inside of the image attribute are all of the symbols, and each of them has a name. So we can type in the name of any objects that we want. We'll see all of these Apple standard symbols that we can use in our app to gain consistency in a conformed or recommended user interface design. We want a rectangle, so I'm just going to type in the word rectangle. I've got a bunch of different options here. I'm just going to choose the default empty rectangle. I'll reposition my button and it looks good. Now I'm going to go back up here again to state config and I'm going to select selected. Now that's a different state and it can have a different image attached to it. So I'm going to go under image and this time I'm going to type in check. I'll select this one here that says checkmark rectangle. It uses the same rectangle we had on our default button state, but it has a checkbox inside of it. Now, unfortunately, when I select this, I don't see the change of state for the button, but it's there behind the scenes. So when I programmatically change the state from default to selected, that image will automatically show up. Now I'm also going to go back and change my default state config to default, and that's all we need to do to configure the two states of the button with two different images. Now I'm going to clear out the default text in the label that says label, press return, readjust the label a bit, and click on Size Inspector, and I want to adjust auto resizing so that it's got this selection in here, centered at the top, left and right margins, and also stretching in the center. Auto resizing for the button is fine. I'm going to build and run now just so that you can see that things aren't quite set up yet. And here it comes. Oh, this is ghastly. What's going on? Well, we're still referring to that default label that's behind the scenes in the standard table view cell. What we need to do is we actually need to create a new subclass of table view cell, and that's what we're going to customize. So just like when we took our table view controller and we subclassed and customized that, remember we created a separate Cocoa Touch class, subclassing UITableViewController as to do detail table view controller, and we use the identity inspector to attach that file to the table view controller. Well, we're going to do the same thing for our table view cell. We'll create a new file. We're going to subclass a Cocoa Touch class. This time it's going to be UITableViewCell instead of UITableViewController. We'll attach that using the identity inspector to our cell instead of the table view controller, and then we can use this new file to hold our IB outlets, our IB actions, and any other code we need to write. So we're going to add a new file. I'm going to do that right under to do detail table view controller. So under the file menu, I'll select new file, select Cocoa Touch class, next. The subclass that we want is UITableViewCell. It's really important that you have that right, not table view controller, but table view cell. Why don't we name this list table view cell, then select next and create. Here's our file. Our new class name is list table view cell. It's of type UITableViewCell. We can highlight and delete everything in between the class curlies. We're going to recreate it from scratch. Now let's option click on main storyboard to get side by side in the assistant editor. Remember what we need to do before we can go ahead and add IB outlets? Let's try to see what would happen if we control drag from the button into our new list table view cell class. We see, oh, there's no option in here to set this as an IB outlet. How come? Oh yeah, we haven't set the identity of this cell to the new subclass we created. We gotta click cancel and we gotta go to the identity inspector. In the document outline, make sure cell is clicked, then click on the identity inspector icon. It looks like an ID card. Under class, pull down, and you can see we've got list table view cell. That's exactly what we want. Select that, press return. That cell has an identity of list table view cell, so we can add IB outlets and actions to that file. Let's start with the button. Control drag from button over into our class. Let's give that the name checkbox button. Click connect. Now let's control drag over from the label and we'll give this the name label. Click connect. Looking good? 2 outlets. Now let's click on to do list view controller. That's where we need to update the code for this table view. And I'm going to use the jump bar to jump down into the extension and go into the table view cell for row at function. And now instead of our old code in here where we're accessing the text label, we want to access our 2 new IB outlets. Just above the text label line, we'll get rid of that in a minute. I'll create a new line, type in cell dot, and now I'm expecting to see my IB outlets in here, but I don't see them. How come? Well, let's option click on cell to get to the bottom of this. And we see that cell is of type UITableViewCell. Now that's okay, but a UITableViewCell doesn't have our IB outlets. What has our IB outlets is the subclass we just created, which is called ListTableViewCell. Hey, we had a similar problem up here. Remember in Prepare for Segue, we have segue.destination, and if we option click on top of that, we say, oh, that's the standard UI view controller. But that's not good enough. We can't get at the properties that we want to get at in the destination, which is subclassed as to do detail table view controller. How do we do the subclass to make sure those properties are exposed in our code? We use as exclamation point. This says, hey, this constant that we're calling destination is going to be taken from segue.destination, but make sure you don't just call it a view controller, but you fully subclass it as a to-do detail table view controller. Well, we'll do the same thing down here. See where we're saying let cell? That's just like saying let destination. We're getting the cell in here from table view DQ reusable cell. What does that return? A UI table view cell. That's too generic. We're going to say at the end here as exclamation point list table view cell. That'll give us access to all of the properties inside of list table view cell by forcing a subclass of cell so it's now of this subclass type. Now watch what happens if we do cell dot. Oh, we see our properties in there. We see name label. We'll select name label dot text equals. I'll highlight and delete the old cell dot text label dot text. Backspace, and now we've got cell.name label is equal to do items indexpath.row.name. Next line, let's get that button for the checkbox in there. Cell.checkbox button dot is selected. This is going to give us a bool value to tell us if it's selected or not. We'll say equal and what do we want it to equal to? Oh, we don't have a value to indicate whether or not that to-do item has been completed. So let's modify our struct and add that property. Click on to-do-item.swift. We see our properties in here. Right at the end, why don't we add a new one? Var completed colon bool. So if it's completed, it'll be true. If it's not completed, it'll be false. If it's true, we want to select the button and show the check mark. If it's false, we'll leave it in the default state with no check mark. So now we can set this button.selected property equal to do items bracket index path dot row dot. You might have to do a shift command K to build so Xcode can recognize that new property. But once you do that, you can do dot and then completed shows up. Perfect. Well, not quite perfect. Remember when we added our isScheduled property, we had to go back and we had to change every line where we created the new to-do item to add that new property? We got to do the same thing again for this new property. But I just went ahead and did a build and run. I see both errors show up exactly where I need to change things in my code. This tells me they're both in to-do detail table view controller. Sure enough, that's what's being highlighted right here. I'm going to highlight everything between the parentheses after creating a to-do item because I still want that stuff. I'll cut it out with Command X and then backspace over the parentheses, and when I do parens again, it offers me this constructor that will list all of the parameters. So I'll press return and accept that one, then I'll highlight all but the last parameter, paste in what I just cut out. Those were those empty values for when I create a new to-do item. Make sure there's a comma between the last parameter and completed, and for completed, since this is where I create a brand new to-do item, I'm going to initially set completed to false because it hasn't been completed. Now there's one more place where I create a new to-do item, that's during prepare for segue, so I'm just going to copy this last completed parameter here, go down to that other to-do item, put in a comma, paste in completed, but here I'm not going to pass back false. I'm going to pass back to do item dot completed. Now, if this value gets changed, it's going to be changed on the previous screen where we click the checkbox. And if we're editing an item, we're just going to keep the value we had there initially. We're not changing it on this screen. We'll pass that back. So now let's build and run and see how things look. And hey, where did my data go? Well, if we look down here into our console, we can see that we have this error, could not load data, the data couldn't be read. How come? That's because our new to-do item class isn't the same as the data that was saved. I'm just gonna go ahead and create some new to-do items. That data will be saved automatically, and it'll be saved over the old stuff, but in the new format. So I'll see it the next time I run the app. I'll say, first item, second item, and here's number 3. That's fine, these are working good. Unfortunately, what's not working is we can't click on the blank rectangles and change them to check marks. We'll fix that right now, and the way that we do that is by creating our own protocol. Now remember, a protocol is essentially a set of rules that you need to follow in order to implement some kind of functionality. So what kind of methods or properties are required for that? Now we've already used a few protocols. Think about what we had to do when we added dynamic scrolling table view functionality. We needed to adopt 2 protocols, so we needed to say UITableViewDataSource and UITableViewDelegate. Once we did that, part of the rules are, hey, you need to have 2 methods. So Xcode offered to put in the stubs of the 2 methods we needed. That's the table view number of rows and section and the table view self or row at. Now in terms of properties, to make this work, we needed to say TableView.Delegate equals self, which is the view controller. And for the data source protocol, we needed TableView.DataSource equals self too. We have to make sure that we set the delegate and the data source for these 2 protocols. Xcode won't warn us. And if we don't do this, our code won't crash, but also our code won't work. So make sure you have that delegate and data source for these 2 protocols. But now let's create our own protocol. We're going to do that in our listTableViewCell.Swift file, and we'll do that right above the class definition, but underneath our import statement. So I'll type in protocol, find it in code completion, press return. It wants a name, so I'm going to give it the name of listTableViewCellDelegate, and make sure that you put :class afterward. That's going to be important. We could have named this anything, but that's a pretty good name. And again, the standard is to use upper camel case for protocols too. And then inside the curlies, we list our requirements. So our requirement is going to be a single function. We haven't written this function yet, but we'll refer to it before we've even written it. And we'll say func, then the name is going to be checkbox toggle. And then inside of our parentheses, we'll say sender, and that's going to be list table view cell, which is the name of the current table view cell where we're putting this protocol in, which means this table view cell can send a message to any view controller that agrees to be its delegate. If a table view controller adopts this protocol and agrees to be the delegate for the list table view cell, then it's sort of like this. The table view cell has the right to say, hey view controller, since you're my delegate, I'm going to send you a message when I need you, and when I send you this message, I want you to execute the function checkbox toggle. So all right, let's set up the rest of this protocol. We need to keep track of which object is our delegate. So underneath, inside of the class, we're going to say weak var delegate : and that's list table view cell delegate. What's the weak all about? Well, at this point you can ignore it. At some point you're going to learn about memory leaks and retain cycles, but right now know that whenever you declare a delegate variable, you've got to do it as weak var instead of just var. Now let's set up an IB action in here attached to that checkbox button that's going to send a message to our delegate and say, hey, now is the time to run that checkbox toggle function just like you promised. So in the document outline, make sure that you find the button that has our checkbox in there, control drag over to create the new function, set the type to IB button, give it the name checkToggled, and click connect. Now in between the curlies, we're going to say delegate ? Now held inside this delegate is going to be the name of any view controller that adopts this protocol. And then afterward we'll say dot, and look what shows up in code completion, checkbox toggled. That's the name of the function that any adopting view controller has to include inside of it. It's part of the protocol, it's part of the rules. If it doesn't do that, our code won't compile. For sender, put in self. Now self refers to this class, which is the list table view cell. So that's what we're passing in, saying, hey, want to know who called this function? It was me. And if you refer to sender inside your function, you can access any of my properties and functions. All right, we just wrote our protocol. We included a variable to keep track of our delegate. We included a function where we can call the delegate and make it run the function that it agreed to include as part of conforming to the protocol. Now let's go over to the view controller to-do list view controller, adopt this protocol, include the required function, and also set the cells delegate to that table view controller. So down here in the table view extension is where I'm going to adopt my new protocol. So after my UITableView data source, I'm just going to say comma. If your list table view cell delegate doesn't show up right away, do a Shift Command K. That'll just reset things in Xcode, and you should see list table view cell delegate to show up. Press return to adopt the protocol. Now Xcode will think for a little bit, but then it'll enforce the rules of the protocol. If we click on this little red circle, we're going to see this error. Just like when we adopted Apple's protocols, the table view delegate and table view data source, Xcode offered to include the function stubs. Well, right here, it also knows about our custom protocol, and it offers to put in that stub too. Let's click Fix. Xcode, go ahead and stub me. And the function is declared. Now before I forget, let's go into the cell for row at function. And when we create our cell, just after our let cell statement, let's make sure that the delegate property of that cell, remember that property that we just created inside of list table view cell, is set to self, which means that the view controller will be the delegate of the list table view cell. So again, if we scroll up here into view did load, just like we said, table view.delegate equals self, which equals the view controller. Now I'll use the jump bar to jump back down to table view cell for row at. Well, down here where we're working with cells, we say cell.delegate equals self. All right, when that cell is clicked, it can send a message. The message is going to go into this function. What are we going to put in this function? We're going to first figure out what cell was clicked. So we'll say if let selected index path equals tableview.index path. You get a bunch of different options in here. Select this one that's index path for UITableView cell. Note what it says in code completion. The description is returns an index path representing the row and section of a given table view cell. That's just what we want. Press return. This function wants a table view cell. How do we get the table view cell? Well, remember this function has a sender parameter that is our list table view cell. So just put in sender. I'll give myself an extra space just so you can see the start of the function. Open and close curlies after the if-let statement. The if-let should never be nil, and as long as it's not nil, it'll execute what's inside this curlies, which means we've got to toggle the selection of the button that holds our checkbox. This is how we're going to do it. If the to-do item for the cell that you clicked on is true, we'll set it to false. If it's false, we'll set it to true. How do we set it to the opposite? If we put an exclamation point before a Boolean value, that turns a false one to a true and a true one to a false. The exclamation point in the beginning is known as the not operator. Let's do it. So we'll say to-do items, bracket, selected index path dot row, close brackets, dot completed, equals the same thing, but with not in front of it, which is exclamation point. Paste the rest of that in there so the not operator will turn true to false or false to true. Then what are we going to do under this? We'll reload the row that we just changed. That will call cell for row at, which will update everything in the interface for this cell. We'll say tableview.reload rows. Remember, it's rows, that weird plural, so we got to put in brackets, but we'll reload selected index path. We'll do that with .automatic. And that's it. We're done. So let's go ahead and build and run. And let's try this out. We'll click in the empty box. Done! Done! Look at this magnificent on, off, on, off, on, off. Wonderful. Our protocol is working. Our button is working. Now there's one problem. Let's see if you know what this is. When I build and run again, let's see. Oh, our checkboxes aren't showing up. Do you think you know how to diagnose where our problem is? Why don't you pause, think about it, and unpause? How about a hint? Think about saving data. Did we save our data each time we made a change? Pause again. Unpause. What we didn't do is we didn't save our data, call our save data function every time we made a change to the checkbox. And remember, we called save data whenever we made changes to data, when we deleted, when we came back from our unwinding from segue, when we moved rows around using the move for row at function. Well, we need to do the same thing when we change the data associated with the checkbox. Let's do that now. This is super simple. Let's just go in here to our checkbox toggle, type in a line right inside this if statement. The last statement will be save data, open and close parens, build and run. Let's check the first box. Let's check the last box. Quit out of here. Build and run again. I'm in app delegate because I quit out of a running simulator. That happens sometimes. No problem. And we see our results and oh, magnificent! It saved our checkmarks. Swifter, you know about protocols. You can program your own delegates. You've got checkboxes working. You are skilled. Keep at it.